Fikri. Assalamualaikum, Fikri. How are you?
Waalaikumsalam, Doctor.
Yeah,
Can you hear me?
yes, very good. All
Um,
right. So, Fikri, where are you now?
Currently, I'm at my home in Indonesia.
Indonesia, very far. Which
Yes.
part of Indonesia?
It's Jakarta.
Jakarta. All
Yeah.
right. So, how COVID pandemic in Jakarta?
It really works because the cases is always increases.
Hmm.
But I got the information that there are 1,000 cases in my city.
All right.
It's
Be
every day.
careful. Be
Yeah. Thank you, doctor.
careful. Please go for the COVID swab, swab,
Yeah.
SWAP,
Yeah.
all right,
Yes.
because you know that earlier, okay, the disease. Don't go outside, stay safe at home. Okay, like me also, stay safe at home. All right, so now thank you very much. Okay, if I ask you a question, you can unmute your voice, all right, at this moment, then you can use your voice. All right.
Okay, doctor.
Okay, don't
Thank
go
you.
out. Don't go. Don't go out. Okay, you stay with us. Okay, you stay with us. All right. Okay,
Okay.
because I want a class live. All right. Okay, I will talk to you later. Fikri. Okay, Abdullah Maurat. Okay, Abdullah, do you hear me, Abdullah?
Yes, doctor.
Yes. Where is your video camera? All right, I want to see your face.
All
Abdullah,
right,
how are you?
all right.
How are you,
Just a
Abdullah?
second, doctor. I'm
How are you,
I'm
Abdullah?
good. I'm good, doctor.
Where are you now? In university, in college? Huh?
I'm living outside the university, but now
Okay.
I'm at home.
All right. At home? At home where? Outside of the university?
Outside the you.
Okay,
Yeah,
okay,
yeah,
very
outside the
good.
campus.
All right. So stay safe. All right. Don't remove yourself. We want to communicate with you. All right. Ahmad
Thank you.
Islam. Oh, how are you, Ahmad Islam? Ah,
Alhamdulillah.
Alhamdulillah. Where are you now?
Here at Johor, Cerebral Aberdana.
Oh, all right, very good. Stay safe, all right? So I
Inshallah.
just want to make sure that my student with me, okay, and then say, and then help, and then be happy wherever you are in Indonesia, in Middle East, in Malaysia, Sabah, Sarawak, all right? So I invite some students. Okay, let's we continue our subject. Scan the attendance and then scan the games, but don't answer because we still not learning. All right, so now let's we share screen. Okay, at this moment, let's we share screen. Okay, I want to share my, where is here. All right, I share here. Okay. Okay, you just answered the question last time. Thank you very much. So many respond. All right. The question here, what type of data for Lagrange and Newton divided? Okay, the answer is not uniform. Okay, the answer is not uniform. All right. And then the second question is, okay, not uniform. What it is? I give you a formula. The formula that I give you is a Lagrange order 2 because we have L, okay, Lagrange polynomial, and then the formula of P, all right, P, polynomial, Lagrange polynomial itself, all right. So from the formula above, how to generate order 3? All right, very good. Okay, many of you answered that we need more data. We need to create a new formula. All very good. All right, but red color is wrong. Just use the formula above. We cannot because we need to create the Lagrange polynomial L with a different formula. Okay, what's different between Lagrange interpolation and Newton divided formula? All right, to solve the problem. Okay, the answer, which one is wrong? So the answer is both use formula. Yes, both use formula only. However, Newton divided use use table, all right? So the red color is correct, okay? So the rest, okay, please do some revision again. We are going to have test 2, all right? Test 2. Okay, now let's share screen. Okay, share screen again. Hello, Abdullah, Fikri, Ahmad Islam, you are here. See, all right? I'm very happy all of you help. Okay, now let's we go to the class today. All right, where is my class? My class is okay. I want to on. Okay, oh, I'm still not insert the material here. Okay, let's I insert. Wait for a while. I put okay. I on my directory. All right. Okay, today class 13 December. Okay, I put here. Okay, you can go to the e-learning, okay, and to get the material for today. All right. So now let's be okay. For this moment, okay, I share chapter 4 on the curve fitting. All right. So at this moment, okay, because we want to make it more clear, no crowded for my screen. So, okay, Abdullah, Ahmad, Fikri, okay, I put you aside, but I'm going to call you again. Don't worry, okay, don't move, don't remove, all right? So now I just focus the lecture for today. All right. Okay, now I want to focus the lecture for today. Okay, it's about the curve fitting. You go to book, okay, book curve fitting 106-109. Okay, this is chapter 4 about curve fitting. What is different between curve fitting and interpolation? This is a something we need to declare here. All right. So you need to answer the question. All right. Curve fitting, okay, we use all the data to generate the linear or quadrant to represent the data itself. All right. So meaning that we need to have a formula, okay, of the curve fitting. There are two types of curve fitting. One is a least square method. The second is linearization. All right. So for today, we are going to finish, okay, the syllabus on curve fitting. All right. When we have a parabolic, okay, graph, whether maximum or minimum, we do the first derivative y respect to x equal to 0 to find the maximum point or the minimum point. So we are going to use this idea. Why? Because when we do first derivative, when equal to 0, we can get the maximum or minimum. We want to focus on minimum. So the error, okay, when we do the first derivative error, okay, equal to 0, meaning that we want to minimize the error. All right. So this is a basic concept. Okay. Second concept is a linear is y equal to mx plus c. You know that. All right. Quadrant is equal to y equal to a plus b x plus c x squared. So there is a square there. All right. So for quadratic. So there are only two graphs. Okay. Quadratic and linear. Two graphs only. All right. So now let's refocus. Okay, let's refocus to our class today. All right. So now, okay, when we said that least square method, meanings that we have two methods. One is a linear least square method, and the other one is a quadratic least square method. All right. Linear means that straight line. Quadratic means that parabolic curve. All right. Okay. So now when we have a data x, I, y, I. So based on the curve fitting, we can draw, okay, two types of graph. We can represent this data into the linear least square method or quadratic least square method. How to do that? To do that, we need to transform the data to the matrix. Okay, in this case, okay, please use calculator. Okay, come on, get ready with your calculator. Where is your calculator? Okay. I want you to focus on stat, okay, quadratic or linear. I want you to focus on VAR, okay, variance. and then I want you to focus on summation and REG, okay, regression. All right, so this is a the point, okay, you need to click, okay. So now, all right. Okay, now let's we continue to the next part is how to generate the linear least square method. That's a focus. Okay, how the formula that we need to create, because some final exam they ask you to create a linear least square method from the data. Okay, this is the way how I write the data. Okay, first in the table, if you go to the page, go to the books. Okay, where is the book numerical? Okay, if you go to page to page 101, okay, go to page 101. Where is your book? Okay, make sure you have a book. 101, there is a data that we are going to use for the whole method, linear and quadrat. Now, okay, we continue again. Okay, now since we have idea how to transform the table to the set of metrics, X is an independent variable and Y is a dependent variable. Okay, means that Y is depend on X. Okay, means that the rainfall, the total of rainfall is depend on the day. All right. So now we know that the linear is Y equal to MX plus C or A plus BX. This is a common, where A and B is constant. So we want to find A and B because we want to train to generate the linear least square from the table. All right. So the second is we need to know what is error. Error is a difference between data we given in the page 101 in the question minus the YXI. This is a data generated from linear least square method, all right, or the function from least square method, all right. So we want to find the error between the data and then the data generated from linear least square method. All right, because the error is sometimes positive, sometimes negative, so we square the error because we want to make the error always positive. So y equal error equal to yi minus a plus, not a minus, yeah. Oh, sorry, a plus bxi. Okay, a plus bxi means that this one is yi minus a minus bxi, and everything should be squared because we want to find error, squared error. So this is the we need to know, okay, yi and then the linear least square method, LLS, a plus bxi, all right? So S is a summation, squared error is a summation ei squared, or summation yi minus b minus bxi, everything squared, okay? So we already know that how to minimize the error. We know already how to minimize the error. So now let's we ask a question from Abdullah, okay, Ahmad, Fikri, how to minimize the error. Okay, I already mentioned the earlier. How to minimize the error? How to minimize the error? Can somebody answer my question? Okay, who are in the same group with me. How to minimize the error? Del S over del A or del B is equal to 0, right? We want to find the maximum or minimum of the error, right? So we need know, okay, we need to do the first derivative respect to A and respect to B, all right? So now let's refocus. It's not difficult, don't worry, because we just focus on the del S over A, the first derivative f respect to A, and then first derivative s respect to b equal to 0, equal to 0. That is the way how to make sure the error is a minimum. Okay, meaning that the data, okay, and the linear least square method, the graph is very close, okay, because the error is minimum. So del S over del A is a 2, come on, this one, 2, power 2, 2 should be bring down, 2 minus 1 is 1. It's similar when you use the first derivative, yi minus A minus, okay, bxi, okay, this one is a minus bxi, sorry, yeah. And then we want to differentiate respect to A, meaning that negative A, first derivative negative A respect to A is a negative 1, all right, negative 1. All right, so this one is a 2yi minus A, okay, plus bxi. Okay, this one is a plus, is a minus bxi power 1, negative 1 equal to 0. All right, so meaning that, okay, you can put a summation for every part. Okay, summation A, summation bxi, summation yi. So the yi, okay, you bring on the left, and then summation A, summation bi on your right hand side. So A is a constant, bring constant outside. You can write A summation 1 plus B summation xi equal to summation yi. What is summation 1? Summation 1 means that 1 plus 1 plus 1 plus 1. Okay, so now if I want to ask a question to Fikri, if I want to find summation 1 from I equal to 0 to I equal to 3, how much the value? Summation 1. Means that 1, 2, 3. So means
2, 3.
you have
There are 3.
okay, if you finish at 2, means that the answer is 3. If you data has a 3, means that the summation is 4. All right. So means that in our case, the data is 5. So the summation of 1 from I equal to 0 to 5 is 6. Okay, is 6. Means that you need to do 1 plus 1 plus 1 plus 1 plus 1 plus 1. All right, plus 1. Okay. So now, let's go to the okay, go the next. Okay, now we want to do the differentiate. Okay, first derivative s respect to b is a summation. Okay, summation yi minus a minus bxi everything. Okay, square. Okay, please, this one should be minus, yeah, equal to 0. So now when you do derivative respect to b, is the answer is a negative xi, because this one is a plus, yeah, negative xi. All right, 2 bring down, 2 minus 1 is 1. All right, and then derivative respect to b is a negative xi. All right, so from here, okay, 2 you divide by 0, 0 divided by 2 is equal to 0. You can get summation a xi plus summation b xi squared equal to summation yi xi. All right. So this is a 2 equation. Okay, bring the constant there. Okay, a summation xi plus b summation xi squared summation si yi. So from the equation 1 and equation 2, you can create a matrix. You can create a matrix, yeah? Ax equal to f. Your f is a summation yi, summation si yi. Your x is a sum a and b. The matrix element is a summation 1, summation si, summation si, summation si squared. All right, so we can write in the matrix form for equation number 1 and equation number 2. Right, so this is a matrix, okay. The right hand side is a summation yi in the question 1, and then question 2 is summation yi. The matrix A is a AB, and then this is the element of the matrix A. Okay, matrix for the Ax equal to F. All right. So we develop this matrix. Please remember why we need to remember, because we want to find summation xi, summation yi, summation xi squared and summation xiyi by using the calculator. Where is your calculator? Okay, so this is a calculator. We want to find summation xi, summation yi, summation xi squared, summation xiyi. All right, how to do that? Okay, to do that, all right, you need to use the, go to the page 1, okay, go to page, let's we go to the e-note, okay, our e-note, okay, go to page, okay, 103, okay, you go to 103, all right, you can see that how we press the calculator. You see how we press the calculator. You need to use what? Mode fix 4 because 4 decimal places, and then press stat to find a linear or quadrat. We are using linear, and then insert the data for xiyi. All right. So this is the way how to make the process of simulation speed. All right. For example, here you go to the example. Okay, please remember. Okay, what is you need to remember? The formula, the matrix for linear least square method. Okay, form the linear least square method. Form. Okay, means that you need to create the matrix. Okay, for the data below. What is the data? The data you can see is uniform, non-uniform. Yeah. So to compute this one, okay, you need to find summation of the square. There's a question. They will ask you to do a summation of the squared error, and then use 4 decimal places to control your answer for A and B. All right. You want to find what is A and B. Apply the formula that you just created, 2 by 2 matrices just now. Find A and B as a constant for y equal to A plus bx plus bx. Okay, y equal to ms plus c, a linear line. All right. You are given the data. The data you can see here is not uniform. H is not similar. H is not similar. All right. The y is increasing. Okay, the process of increasing sometimes linear, sometimes quadrat, but we want to use this data as a linear. So we force the data to be linear, all right, by using the linear least square method. We force all the data will be used, okay, not a specific, okay, like interpolation, we are going to focus on the specific data, all right, but here is all data will be given. So let's y equal to a plus bx is a linear. Okay, this one you need to know. Okay, this is a linear function for the data given. This is our assumption. Okay, so our assumption is what? Okay, let's I continue. Is we force the data to be linear. Actually, the data should be quadrat, should be okay, maybe cubic, but we force the data be linear. All right. So we want to use all the data, get a summation of the data Si and Yi, and then create the linear least square method. Okay, linear least square method. All right. So this is the step that we are going to use. All right. So now, okay, we know that the data from I equal to 0 to 5. You know, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. All right. So we want to find AB because we know that the data is a linear. We want to use the formula of linear least square. The matrix is 2 by 2 times AB, and then summation of F is a summation YI, summation SIYI. So the question here, how to find XI squared YI, okay, summation SIYI. So I told you summation I equal to 0 to 5, number of data maximum is 5, is equal to 6. All right, because how to get 6? Come on, count your hand. 1 plus 1 plus 1 plus 1 plus 1 plus 1. So the answer is 6. All right, because the data is 6. Start from 0, 1, 2, 3, 4, 5. Right, so you have 6 data. So this one you need to be careful. Okay, you need to be Careful. So the answer is 6. So one data is already done. All right. So the next data, you need to press your calculator. Come on, we press the calculator. Insert the data. The first is you need to press what? Go to page 103. Okay, mode fix 4. Press that. Find linear a plus bx. Okay, go to 103. Right, 120. Insert the data and insert the data for xi and yi. Okay, go to page 103. So this is the way how you do. Okay, first you need to mode fix 4 and then press that and then create the linear y equal to ax. Okay, y equal to a plus bx. Insert the data, start from x1, x0, x1, x2, x3, x4, x5. Continue to y0, y1, y2, y3, y4, y5. All right? Okay, and then after that, what should you do? Shift stat. Okay, shift stat, you can get number 4 for variance. Okay, summation. Variance is n is equal to 6. Summation of xi, all right, is equal to 8.8. And then summation of the xy squared is 13.76. Summation y equal to 13.2. Summation xiyi is equal to 20.345. All right. So now, to get A, you need to use regression. How to get regression? Shift stat. Okay, press 5 for regression, and then you can get the value of A through the calculator, 0.507, and B is 1.1543. All right. So now, okay, can you try? Okay, can you try? Be careful when you insert the data. Be careful. All right. Go to page 103. All right. Okay. This is a talent for you to get the data. All right. So come on, try to press your calculator. And then Albara Rafai said that, doctor, how about the test mark? I will send to you. All right. I will send to you because I promise I will post to you who are the has a high rank, high marks. Okay, I post to you because we cannot go to the class, so I post through the delivery. Okay, the gift from me, appreciate. Okay, because you have a good marks. Okay, I post to your home. I address you as your home. All right. So never mind. Okay. Do you get A and B? Apa? Fikri, Abdullah, Ahmad Islam. Do you get A and B? Do you follow the book in 103 page? Okay, page 103. You get the value A or not? Okay, so I want.
I'm trying, doctor. I'm trying. I'm still trying.
We don't have to create the table. Yes, you need to create a table, but at this moment, you are using calculator to create the table. I don't want you to create x plus x0 plus x1 plus x2 plus x3. I don't want. All right, because this really take time consuming. I don't want to you to find x0 squared, x1 squared. Okay, 1.1 squared, 1.3 squared. Okay, 1.5 squared. I don't want, because okay, this is time consuming. I just want you to use calculator. Okay, and then okay, my question, who get? Okay, I want to know who get A and B. Okay, from the audience. Okay, from the class here, who get A and B? My question here. All right, may I know who get A, the correct value A and B? All right, I'm waiting. So you can see here, I'm not applying in the table because it's really waste the time. You need to answer in the 20 minutes. All right. So you draw the table. You use arrow. You need to find summation xi, summation yi, summation xi squared, summation xiyi from the formula of least square method, you use arrow. You no need to fill up all the value of xi naught, x, okay, x1 squared, x naught squared, okay, x naught y naught. Okay, we just want to find a summation that you get from the calculator. No need to write all the value. You just find the value which is you use in the matrix 2 by 2 linearly square method. All right, so fix in what is summation x, summation 1, summation x, summation xi squared, and then summation xi yi. Okay, you just fit in the table like this. Okay, you see how fast, okay, who get, oh, very good, very good. All right. Okay, because this you good your answer why I'm not create the table later. I just want you to use the calculator. Okay, from the calculator, no need to find what is a 1.3 squared, 1.5 squared, okay, xiyi, okay, x naught, y naught, x1, y1. Okay, we don't want to find every element of the table because it's waste your time. I just want you to find summation xi, summation yi, because the formula is a matrix, okay, linearly square method 2 by 2 involving the value of summation 1, summation xi, summation yi, summation xi squared, summation xiyi only. So from here, okay, you can use your calculator. Actually, you don't need to use calculator. It's just get from the above answer, kan? Okay, you get from the above answer. Okay, go to the above answer. Right, you already done from the calculator the value of A and B. Okay, already done from the previous step. See, the previous step, you know what is A and B. However, since you are showing the step, okay, so you use the matrix, okay, 2 by 2, AB, and then F1, F2. So A is a 0.507, B is 1.543. So what is mean? It means that the data that I give to you, you force the data to be linear. All right? Y equal to mx plus c. What is c? C is a go through the y-axis. C is they go through the y-axis at the point 0.507. All right? You already remember the formula y equal to mx plus c. Okay? M is a gradient. Gradient is a positive 1.1543. So you force the data to be linear. So guna arrow saja. Alright. So that's a problem that we want to solve now. Alright. It's a matrix. Okay. And then you want to force the data to be a linear using the matrix of linear least square method. All right. So till now, any question? Okay, any question from Azari, from others? Okay, any question for the linear least square method from Abdullah? Okay, from Ahmad, from Fikri. All right, any question? Do you want to share screen? Do you want to share screen? What are you? What you want to? What you already done with me? You want to share screen? Take photo. You want to share? I allow you to share screen with me. All right. Anybody want to share screen with me? Any question? Yes. What question?
It's very clear, doctor, from me.
Any question? No question. Okay. 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 Yelah, good. Nanti masa exam risau juga kan. Alright. Alright. So now let's we share screen again. Alright. Okay. Now let's we share screen again. Alright. There is no question. Now, how I want to use the same data? I want to train the data to be quadratic. Okay. I want to force the data to be quadratic using quadratic least square method. All right. So let's we go how to do that. All right. Okay. We know that. Okay. We know that the quadratic is a parabolic is equal to x squared. Okay. Should be have x squared. means that I can write as a plus bx plus cx squared. So there is a plus cx squared to show that the graph is a quadrant, is a parabolic. Okay, I need to go through all the case. Okay, the first is, okay, minimize the error. Error is between the data and then the quadratic graph that you are going to generate. All right, how to minimize the error? By first derivative s, okay, respect to a, derivative s respect to b, first order derivative s respect to c equal to 0. That I already done. Okay, to get a minimum of s, you need to do the first derivative. Second, all right, you, as usual, you need to develop a metric form for the quadratic least square method. How the metric form? It should be 3 by 3. All right, it's not 2 by 2. Kalau linear, is a 2 by 2. This one is 3 by 3. So this is a 4 step we need to go through. All right, I'm afraid they ask you to prove the formula of the quadratic least square method using the minimizing errors. Okay, minimizing square errors. Okay, now let's redevelop. Okay, we know that the quadrant is a plus bx plus cx squared. Squared to means that parabolic. All right, squared is a parabolic. So error we know already, the difference between data and the quadratic least square. All right, we know already. I explain the second time. But the yxi is different. It's very long here. It's 3 terms. Okay, a plus bx plus cx squared. Okay, error is a difference between data and the quadratic least square method. All right. However, the summation squared error is a summation xi squared. That's we call as a summation squared error, which is a yi minus a plus bx plus cx squared. All right. And then you need to square all the function from I equal to 0 up to n. And then to minimize the error, we use first derivative s respect to a, right? This is the first part, right? You need to remember, all right? Okay, now let's go to the summation yi minus a, okay, plus bx plus cx squared. Because minus, so I think I put all the function is minus, okay? Don't forget square, okay, power 2 square from I equal to 0 up to n. And now let's go to the first derivative s respect to a equal to 0. Minimize the error, must be equal to 0. First derivative s respect to b is equal to 0. Okay, I told you to minimize the error, you need to first derivative equal to 0. Okay, first derivative c s respect to c is equal to 0. Now, let's go to the differential of s. Okay, differentiate s respect to a is to bring down yi minus a minus bx I minus cxi power 2. Okay, power 2. And then 2 is minus 1. Now 2 is minus 1. Okay, in the column, 2 minus 1 is 1. And then now we want to do the first derivative respect to a, should be negative 1. So where should I put negative 1? I drag equal to 0 on my right. So I put negative 1 here because I do the derivative respect to a. So negative 1. All right. For b, okay, the same formula. But first derivative respect to b is a negative xi. Okay. Negative xi equal to 0. All right. So times negative xi equal to 0. All right. Okay. We want to do derivative respect to b, negative xi. All right. And then the same thing. Okay. The first derivative as respect to c. C, if you want to do the first derivative respect to c, is a negative xi squared. Xi squared. So now, means that you need to find the summation up to xi power 4. What? Okay, power 4. Alright, so now let's go to derivative respect to c is a negative xi squared. I hope you know how to do the first derivative respect to A, B, and C. All right, same as a linear. Okay, what should the next step we need to do? So now I want to share with Abdullah Murad, Ahmad Islam. What the next? After we do the first derivative respect to A, B, and C, the next step is what? Okay, what is the next? What is the next step?
We put it in matrix.
Yes, very good, Abdullah. Very good, Abdullah. All right. So come on. Okay, we focus how the matrix that we are going to obtain. The matrix is a AX equal to F. All right. Your F, you know, your matrix is to be 3 by 3 because parameter you want to find is a ABC. Is a ABC. All right. So the parameter ABC, this one is your matrix X. The F function on the right hand side is a summation yi. Summation from here you can see summation xi yi and then summation xi squared yi. All right. And then the element of matrix A, the big matrix 3 by 3 is what? Is a summation 1. Okay, because A kan, A summation 1, summation X, summation xi squared. Okay. For the second line for matrix is a summation xi, summation xi squared, and summation xi power 3. Go to the matrix there. All right, above there. You can predict. And then now for the third line, summation si squared, summation si power 3, and summation si power 4. All right, so this last one. Okay. All right. So now what we want to do is find A and B and C. Use calculator to find summation 1, summation si, summation si squared, summation si quad, summation xiyi. All right. So in this case, okay, you need to use the calculator. Where is your calculator? Again, I want to see your calculator. Okay. In this case, you replace from linear to quadratic. Okay, from linear to quadratic. The rest you can insert. All right. So now, Piraveen. Okay, Piraveen. Who can press the calculator? Who can explain to me how to press the calculator? Can somebody explain to me how press the calculator? Fikri, Abdullah, Ahmad, can you press the calculator? The first we need to do, okay, mode fix 4. Okay. Second, use the calculator. Where is your calculator? Go to page 108. Okay, 108. And then you know what is how to find var. Okay, var is shift stat for var. How to find sum, shift stat 3 is for sum, and reg is a shift stat 5 for reg. All right. So now I'm using the same data. I told you, okay, I'm using the same data, the same question, but I want to train the data to be quadratic least square, right, function. Okay, you are given the data. X0 is 1.1. Okay, S1 is, you go to the data, 1.0, 1.1, 1.3, 1.5, 1.9, 2.0. Okay, 1.46, okay, is a data that I give you. 1.46, 1.67, 1.31, 2.45, 2.5, and 2.81. All right, so I give already the data. So now, by using the quadratic least square method, okay, that you get from the above matrix, we want to generate, okay, y equal to a plus bx plus cx squared, because this is a quadratic, cx squared, all right, from the data above. Data, we are using the same data from the linear least square method. We want to find the error, okay, and then we want to use the calculator to find what is a summation 1 from 0 to 5 equal to C, Summation SI is 8.8. Summation SI squared 13.76. Summation SI power 3 is 22.762, and summation SI power 4 is 39.4148. All right, so press the calculator, try, insert the data. Try. All right, okay, press your calculator. You can find all the value, all right. Okay, just insert to the quadrant, okay. Okay, SIYI, be careful when you insert, okay. All right, so can you find what is A, what is B, what is C? Okay, this the next step is what is the next step? The next step is find A, B, C. From the calculator, you know already what is the value of the A, B, C, right? A, B, C. Okay, come on, continue. Please be careful when you insert the data. The same data I'm using, but I just press quadrat, okay, from linear to quadrat. So the summation yi, what is the value? Same as before, 13.2. Summation siyi, same as before, all right, same as before, all right, is a 20.345. All right, you need to find also summation SI squared y. This one you cannot get from the previous data. Okay, this is from the quadratic least square method. All right, and then okay, you also press the rate. Okay, regression. Okay, is a equal to negative 3.0118. B is 6.1219, and C is a negative 16428. So actually, just from calculator, you know all the answer. Okay, all the matrix, all whatever in the matrix here. Okay, where is the matrix in the formula here? Okay, you use calculator and then you get the value. Don't forget you need to insert, okay, the correct X and Y. Yeah, X and Y. All right. So then what is the next step? So that I told you what is the next step. So what is the next step? Okay. Many times I said what is the next step? The next step is insert all the value in the matrix. Okay. Matrix 3 by 3. Okay. What is the next step? You need to insert to the matrix 3 by 3 quadrant least square method. Yeah, quadrant least square method. All right, so when we insert the value of summation 1 is 6, summation si squared, already done, okay, from the calculator. Summation xi power 3, all right, summation xi power 4, all right. So you just, okay, take the value from the calculator and then draw the table, okay, because we want to make sure that people know where is the answer, all right, from the table. So you generate si squared, si power 3, si power 4, siyi, si squared yi from data 0 up to 5, right? So summation 1, I equal to 0 to 5 is what, all right? You just use arrow that I told you. Use what? Use arrow. All right. No need to count one by one. Why? Okay, because it's wasting your time. No need to count. Xi squared. Okay, it's a 1.0 times 1.0. X 1 squared. 1.1 times 1.1. No need to fill up all the element in the table. You know, it's wasting your time. We want you to find the last value. Okay, so come on, I said that no need to find every particular element in the table. Okay, why? Because it's really waste your time. Okay, Okay, every element in the table. Why? Because it's waste your time. We just want a summation of xi, summation yi, summation xi squared, summation xi power 3, and so on. No need to fit in. You know why? Because I told you there is a easy get from the table, from the calculator. All right. So no need to insert all the element until si squared yi. Okay. Okay, what is the next step? So what is the next step? The question here is what is the next step? The step is I want to answer what is the next step. Okay, you fit all the answer in the table. Okay, table of the quadratic least square method. Insert. Be careful when you insert. Don't miss. Okay, don't misplace. So summation 1 is 6. Summation xi. Okay, you get already from the calculator. Summation yi, you get already from the calculator, 13.2. Summation SIYI squared is 13.1621. Summation SI squared is at 13.76. Summation SI is at 8.8, you get from the linear before. Summation SI squared is at 13.76, also you get from the linear data before. And then you add what is a summation SI power 4, summation SI power 2. This one you need to get from the calculator straightforward. All right, by using a regression, you know what is A, or you can press in the calculator, okay, linear system of equation, what is A, B, and C. All right, so what is the impact? Okay, what is the impact? What actually you want to try explain here? All right, what is the impact? The impact here is you already transform, okay, from the table to the quadratic graph, to the parabolic graph. You see here, parabolic. You transform the data, okay, to the parabolic. Okay, you can see parabolic is the error is much more lower than linear. Actually, the data is a look at parabolic. Okay. Okay. Before that, all right. Before that, I would like. Okay, what is the objective here? We already transform one data set to the linear or to the quadratic. All right, by using the calculator. Go to exercise 4.1. Okay, exercise 4.1. Okay, okay, we are in chapter 4. 4.1, you see, there are 4 questions here. I will distribute the question, all right? And then I hope I will get the answer. The last question is so many data. Is how many data? 0, 1, 2, 3, 4, 5, 6, 7. It's a 7 data. Meaning that summation at 1 is at 8. Summation 1 is at 8. It's a big data. All right, it's a big data. So be careful because you need to do a summation. Summation xi should be what? Should be 0.2 plus 0.3 plus 0.6 until 1.5. All right. So the data is what? The data is non-uniform. It's not uniform, right? So what is a curve fitting? You generate, okay, the linear or quadrate from the data given, all right? We are using matrix. Why? Because you try to minimize the error. When we do the minimizing error, they will generate the matrix because first derivative s respect to a, b, c will minimize the error. So you can see, okay, from the quadrant and linear compared to the data, the error is much more smaller. Okay, quadrant much more smaller than linear. Right, try 4.2. If you go to 4.2 page 4.2 page, okay, 111, okay, 111. From here you can see you are using the same data, but you force them to be quadrate. Of course, the answer is, okay, the result from 4.2 better than 4.1, all right, 4.1. All right, so however you, in the graph, make sure that you use arrow, no need to find every element, okay, in the table, okay, because we have no time. Okay, since this is new for you, what should you do? Okay, this is I want to motivate you. I want to coach you Okay, you find other example. You try and compare the answer at the back of this book. Okay, you can see that if your answer correct, means that you know how to press the calculator and then fix to the matrix and then get the value AB or ABC. All right. So how many four step? What is a four step? The first is you create the formula of linear or quadrant by minimizing the error. Second, okay, you find the error, which is a del S over del A, del S over del B, del S over del C. All right. The third is you transform to the matrix for linear or quadrant. If the matrix 2 by 2 is a linear least square method, if matrix A is a 3 by 3 is a quadrant, okay, least square method, and then the rest is find the constant A, B, C. All right, if the way you want to do is a quadrant. All right, so now, okay, I stop sharing. Okay, now, okay, what should I want you to do? Okay, I want you to go to here. Okay, I want you to go to, I go to another question. Okay, this is a question. I hope I share with you. Uh-huh. Okay, this is a question. Okay, let's relax, make it bigger. Okay, writing here, I think it's much bigger. Okay. All right, the question here, what is the difference between interpolation and curve fitting? Which is wrong? Okay. Okay, the interpolation, so you can answer this one. I hope you can answer this question. Wow, already respond. I don't want to on the respond, but I want you to answer which is the correct answer. Okay, which is wrong? Which one is wrong? Which one is wrong? So I sent already the QR code, okay, to your Telegram. If not, I'm going to send the link. Okay, I will send you a link. All right, Control C to your. Okay, go to the link. Okay, go to the link. You can find the form. Okay, thank you very much. Okay, all right. Okay. Mm-hmm. Okay. So you can answer until tonight. Don't worry. I give you until 12 o'clock tonight. Don't worry. But try to understand and then try to answer. All right? Mhm. Okay. Now, I want to share with you the e-learning. Okay. I stop sharing. I want to share with you the e-learning. If I can go to my e-learning. All right. I'm going to my e-learning now. All right. Where is my e-learning? Is here. Is here. All right. Okay. Mm, okay. I'm sorry. This one. Okay. I don't know why it cannot work now. Okay. I go to this one. The e-learning. Okay. I stop sharing first because okay, since you are waiting, okay, wait. Okay, it's very slow. Mm-hmm. You go to my e-learning, you can go to your e-learning. There is a PDF file of the notes, okay, and also there is some quizzes, okay, it's also included in the Google form, okay, you can find that. And then the link today, okay, I'm going to go to the, I want to insert to the YouTube, all right, at the e-learning. All right. So e-learning is going on. You can go to the this week. Okay, very slow. I don't know why. Okay, never mind. We go to other alternative. Okay, stop sharing. Okay, we go to the let's we go to the e-learning. Okay, share. Okay, when you go to the e-learning, okay, okay, because you are using, you also go to the same. We are going to the same what? Same part here, right? So what? So we are having a problem, okay, because we are using a same server. All right. So let's we go to another. I'm fine to another cloud. Okay. Come on. We go to the.
I think we should go or what?
I think it is N.
Yeah, the doctor
Because
just
it's
write in the
N.
group. Check the Telegram, guys.
Yeah, yeah. Okay, okay. Thank you, guys.
See you guys.
Okay, thank you.